Welcome back to The Foundry by Forge College. Let's jump right into today's explainer. Now, as part of our broader dive into Solana development tools and the whole development environment, we're putting on our engineering hats and heading straight to the testing grounds. In our last lesson, you might remember, the local deployment workflow with Solana CLI, we successfully deployed our local Solana program. We basically built the machine. But, as any engineer will tell you, a deployed program sitting idle is really just a super expensive paperweight. So today, we're adding the transaction fuel. We're going to run our first true engineer's test flight, learning exactly how to manage life cycles, read the telemetry, and honestly, just make sure everything is humming along perfectly without, blowing up the lab. So, here's our test flight blueprint for today. First, we'll cover the transaction lifecycle. Then we'll look at preparing the local environment. After that, invoking your program, followed by confirming and reading logs. And finally, we'll wrap up with the verification artifact.
All right, let's kick things off with Section 1, the transaction lifecycle.
This predictable sequence right here, it's the absolute heartbeat of local Solana development. Think of it like a continuous loop. First, we pack the instruction payload. Then, we assemble it into a transaction and basically seal it with a crypto signature. Step 3, we launch it over to the validator. But we definitely don't just walk away and hope for the best, right? Step 4 is confirming it actually landed. And step 5 is diving into the validator logs to see exactly how the gears turned inside. Trust me, you are going to repeat this loop countless times. Let's zoom in a bit on that very first step. The instruction payload is your atomic unit of work. It's the core set of directions your program is going to decode and execute. And it really requires 3 absolutely vital pieces of data. The program ID, which tells the network exactly which contract to wake up, the account meta list, detailing exactly which accounts are going to be touched, and an opaque data buffer, which is honestly just the customized argument you're passing in. Okay, moving right along to Section 2, preparing the local environment. Before we launch anything, we've got to make sure our tools are pointing at the right target. So we run this command, solana config set, URL localhost 8899. The absolute last thing you want is to be iterating on some buggy test code and accidentally launch your test flights on the mainnet with real money. No way. This command securely locks us into our free local sandbox. Next up, we need some fuel. And honestly, the beauty of local development is that we literally have our own legal money printer. We use the command Solana airdrop 1 to print some free local SOL and fund our fee payer. Every single transaction requires a tiny bit of compute fuel. Always double-check your local wallet balance before a test flight, because otherwise, your transaction is going to fail before it even gets off the launch pad. Which brings us to Section 3, invoking your program. Now, on the CLI side of things, we typically aren't hand-coding binary data to invoke our programs. I mean, that would be an absolute nightmare. Instead, we run a simple client helper script, usually written in Node.js or Rust. This script elegantly constructs our instruction payload, signs it using a local key pair, which acts exactly like a cryptographic wax seal proving you authorized it, and then it submits the whole batch right to our local RPC. The absolute second your client's script submits that transaction, the network hands back a transaction signature. It's a unique base 58 string. I want you to treat this string like your ultimate FedEx tracking number. Seriously, do not lose it. It's your primary handle, your receipt, and your anchor point for absolutely everything we do next. Now for Section 4, confirming and reading logs. Here's a question that catches a ton of beginners completely off guard. Your transaction was sent, your terminals spit out a nice long string. But did it actually work? Well, sending does not equal success. Just because the network accepted your payload doesn't necessarily mean your program's internal logic executed successfully. We have to verify it. Sometimes that wall of matrix-like terminal text can feel a bit overwhelming, but it brilliantly maps directly to practical developer actions. When you get the transaction signature, your action is to run Solana confirm. When it spits out the slot number, you cross-reference ledger activity. When you see the commitment status, you wait. And most importantly, when you pull the program logs, you use them to trace your control flow and spot any runtime errors. Literally, every piece of output has a job. Let's talk about commitment status for a second. We actually monitor the transaction through 3 timeline stages: processed, confirmed, and finalized. Even when you're just in local development, it's a massive best practice to wait for a confirmed or finalized status before you actually trust that any state changes took place in your accounts. For the ultimate truth, we run Solana logs with a URL localhost 8899.
By keeping this command running in a totally separate terminal window, we get to read the decisive functional verification in real time. This is it, the moment of truth. Did the program print your expected success message, or did it just emit a terrifying runtime panic trace? If you instrument your code well, this command is going to be your absolute best friend.
And finally, Section 5, the verification artifact. Listen, if there is one golden rule you take away from this entire explainer, let it be this. Treat the transaction signature as the single source of truth. That signature string is the absolute anchor point for all your debugging, log fetching, and confirmation checks. It is the undeniable proof of exactly what happened. As you'll quickly learn, great developers always document their test flights. Whenever you validate a program change, you should absolutely compile a transaction demo artifact. This includes the CLI commands you ran, the resulting signature, the confirmation output text, and those extracted program logs. Compiling this clean, reproducible record basically proves beyond a shadow of a doubt that your code works, and it gives you a flawless starting point if you ever need to roll things back. So you've mastered the manual test flight checklist. You can build, sign, send, confirm, and inspect with the best of them. But looking at this engineering loop, I want to leave you pondering a question. How will you automate this for your next launch? How do you turn these manual CLI commands into a totally seamless testing suite? Well, that is exactly what you should be thinking about next. Thank you so much for joining me on this explainer by Forge College. To dive deeper into automated testing and basically everything else Web3 related, definitely visit us at forge.college. Keep building, keep testing, and I'll see you in the next one.